All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And since today we're talking about junior pen tester and what the shell, we are going to stay as favorite system network attackers here. We are going through this room called What the Shell, and as you can tell, it's about shells. Look at that, I'm rhyming. And this is a part of the Privilege Escalation module of Junior Pen Tester pathway in TryHackMe. And I've already done these two introductory rooms for Linux Privilege Escalation and Windows Privilege Escalation. So you can find those two rooms. There's actually several rooms on Linux and Windows Privilege Escalation. But as I was reviewing all the videos and reviewing these rooms, I realized that there is no actual basics room on shells, and so, or there's no basics video, excuse me, on shells. So we are now going to record this video. As you can tell, this is something that I've already completed, but since there is no video on it, I didn't want to leave you hanging. So we are now going to record the video for What the Shell. If you are studying for your Pentest Plus or Security Analyst or Ethical Hacker or any of those certifications, I invite you to like, subscribe, and turn on that notification bell for this channel. Everything that we talk about on this channel has to do with hacking and penetration testing and cybersecurity and all that stuff. So all these things are actually going to be applicable to you in your studies for your certifications as well as your day-to-day job as a pen tester or a cybersecurity analyst. So I think you'll get a lot of benefit out of it. I do answer all of the questions that come in. And more importantly, or at least in my opinion, I would love to have you as a part of our community. We've had a beautiful growth in our community, and there are a lot of awesome people that have joined us from all over the world. And it would just be amazing to also have you tag along on this journey of becoming hackers together. So without further ado, let's jump into the intro to this room, which is what is a shell? All right, before we can get into the intricacies of sending and receiving shells, it's important that you understand what actually a shell is. So the simplest way that we can put this is when you can interface and interact with a command line environment through another machine. So, my machine connecting to your machine and connecting to your command line, but from where I am, that's called a shell. When you can literally have a shell on your own computer, and when you open up your terminal and your command line, PowerShell, anything like that, that's considered a shell. Literally, the name PowerShell implies shell, right? cmd.exe is another version of a terminal or a command line interface that is called a shell. If you go into a Linux or a Unix computer, it's either bash or sh, but it's still called a shell. So anytime that you just open the command line, you are inside a shell. Now, the entire purpose of this room is about other types of shells, or at least the types of shells that exist. And two specific, general types of shells that exist are the reverse shell or a binding shell. And then we'll talk about what that is in a lot of detail, and we'll even go through some examples here. But when you go to a remote server, so when you connect to a remote server and have that remote server connect back to us, it's called a reverse shell. And then when we open up a port, which we can connect to in order to execute more commands, that's called a binding shell. So when we create, for example, an msfvenom reverse shell, and we've done this a lot in a lot of different videos, this is going to be, it's going to seem very, very rudimentary and very fundamental and almost boring if you've seen any of the other videos and you've already gone through a lot of those pen testing exercises. But if you've never seen them, then this will kind of be a nice foundation for you. Even if you have seen them, it's good to have the foundations and understand what all these things are. When we create a payload using msfvenom, and then we send that payload to the victim machine, and from there we create a Netcat listener on our attack box machine, and then execute the payload, and we receive that shell connection from the victim to our attack box. That's called a reverse shell. And again, we're going to go through, I'm kind of getting ahead of myself. and I probably shouldn't be explaining all this before we actually even go into it, because it's literally right here. There's going to be, it's in the types of shell portion where we actually look at reverse shells and bind shells. So I definitely am getting ahead of myself, so I'm not gonna get ahead of myself anymore. We're gonna go through the actual room itself, and then there's gonna be two machines at the very end that we're gonna interact with. One of them is gonna be a Linux machine, and one of them is gonna be a Windows machine, so that you can see what all of this looks like in practice. Okay, so I've kind of jumped ahead, so sorry about that, but let's go into the next piece of this, which is the tools that are available in our shell room and our overall shell environments. All right, so here we go. These are some of the tools that are available to us. So Netcat, as I already mentioned, it's considered the Swiss Army knife of networking. So you can create a Netcat listener for reverse shells, or you can use Netcat to connect to something. It can manually perform all kinds of network interactions, including banner grabbing during enumeration. But what we're trying to use it for is receiving reverse shells and connecting to remote ports for bind shells on a target system. They're unstable, which means that they can easily be disconnected, and it can be improved with some of the techniques that we're going to talk about. Then there's Socat, which is a more stable version of Netcat. And this is vastly superior, as they say. I haven't used it a lot. I know that it's available. We use Netcat way more frequently in a lot of our videos and our exercises, but I think you can also use Socat essentially to achieve the same results. So there are two big catches with Socat. The syntax is more difficult than Netcat, and Netcat is installed on pretty much every Linux distribution. Socat is rarely installed, so you have to install it yourself. Both of them work, and there's workarounds to both of those, and we're going to be talking about those in a little bit. And then both of them also have executable versions that you can create as a payload for Windows. And then we have Metasploit, the multi-handler, which is actually a shell that is inside the MSF console. And then we have msfvenom to help us create payloads and reverse shells and things like that, so that we can put them inside of the victim machines and then generate reverse shells and all that stuff. So these are just some of the tools that are available at our disposal. There's already a lot of different repositories in different languages that you can go check on GitHub. One of the most famous ones is the Payloads All the Things, which is on GitHub. And then there's the PenTest Monkey reverse shell cheat sheet that is also usable. And so this is what payload all I mean, it's a GitHub repository, so they all look pretty similar to each other. But then if you just look into it under reverse shells, there's a lot of stuff here. So there's Bash, TCP, UDP, C language, Dart, Golang, Groovy, Java, Netcat, Perl, PHP, PowerShell, Python, Ruby, a lot of stuff. And this is Payloads All the Things. And then we have the reverse shell cheat sheet that's on Pentest Monkey that is just literally what it implies. It's a cheat sheet for reverse shells that you can use on a variety of different languages. So that is it for the tools that are available to us. So let's actually look at the different types of shells that exist. All right, at a high glance level here, we have reverse shells is when the target is forced to execute code that connects back to our computer. So the victim connects back to us. On your computer, you would use one of the tools mentioned previously to set up a listener, and then that listener receives the connection from the target. Reverse shells are a good way to bypass firewall rules that may prevent us from connecting to arbitrary ports on the target. The drawback is that when you create a reverse shell from a machine across the internet, you need to configure the network that you're on to accept that shell. Otherwise, you can't. This is not going to be a problem on TryHackMe because of the fact that we're using either a VPN or we're using the attack boxes that are here, so it's a little bit easier. But if you're not inside a controlled environment like TryHackMe, you got to do the configuration part with your network so that you can actually receive the shells. Bind shells is when we execute a code on the target and the target listens and then we connect to it from our attack box. So this is opened up to the this would then be opened up to the internet, meaning that you can connect to that port from your machine, excuse me, using remote code execution that way. And it doesn't require much configuration on your network, but it's prevented by firewalls, because usually to be able to execute something like that on the victim machine, on the target, there you have to bypass the firewall or their IDS or something like that, and that has its own version of challenges. So reverse shells come from the target, so they come back to us and we have the listener. Bind shells have the listener on the target, and then we connect to that from our attack box. So as a general rule, reverse shells are easier to execute and debug. However, we're going to do both of these things, so let's not worry about that. This is a reverse shell example. So on the attacking machine, which is our attack box, we're going to create a Netcat listener. So sudo is just running it as a root or administrator privilege. You create a Netcat listener, and you designate the different flags that you want to have, and you're going to be listening on port 443, right? On the target, you're going to do Netcat, but then you're going to use the attack box IP address. So there's no, in this, notice that there's no IP address or anything mentioned. It's just saying, hey, we're going to create a Netcat listen. So that's what L stands for. And then we want to listen on port 443. On the target, we're going to do Netcat. On the target, we're going to do Netcat, and then we're going to do local IP, which is our attack box IP address, the port, which is 443, and then we're going to execute a bash shell. And that's basically it. And then, so this is what it will look like. On the attack box, it's right here, right? You say, who am I? I'm Murray. And then you run the listener. And then once it, on the victim machine right here, you're going to do who am I shell. And then you do the Netcat, and then connect to the IP address of the attack box here. You execute a shell, and then so it says I am shell, right? So on the victim, the who am I is shell. On our attack box, the who am I is Murray. You execute the listener. Once you've done it, you run who am I again, and now you're shell. So you've connected these two machines like this. So it's very, very high level overview, very basic overview of that. And then this is the bind shell example. So on this one, remember, on the attack box, we ran the Netcat listener. On this one, on the target, you're running the Netcat listener, and you're going to run it on your port, designated port. You want to execute the command exe, which is basically the terminal for Microsoft or Windows. And then on the attack box machine, you're going to do Netcat, and then the IP address of the victim, and then the port number that we want to connect to. So right here, this is also what it looks like. Maybe if I do this, it's kind of a little bit easier to look at it. So this is on the attack box. So it says Netcat, and then the IP address, and then on the port. And this is the one that's running on our victim machine. So they did evil WinRM to actually connect to it first. So this section right here, to kind of disregard this section. They've done this so that they can connect to the Windows machine. Once they connect to the Windows machine, you see that it changes from Murray to the PowerShell and then users administrator documents. And then so this is now them being inside of the Windows machine. And then from here, they run Netcat, LVPN to create the listener. They want to execute a command, executable, the command line right here. And then Netcat is now listening on port 8080. And then once this thing actually connects, you'll see that on our attack box, we see users administrator documents. So we are now inside of the Windows machine from the attack box. This part at first kind of confused me, because I thought that the evil WinRM thing was something that was included in the reverse shell creation, but it's not. This has nothing to do with it. This is just them connecting to the Windows machines for the sake of this exercise, which it's kind of confusing, but you get it. You get what's going on. So now the final concept is the concept of interactivity, which is that shells can either be interactive or non-interactive. And what that means specifically is that if it's interactive, you can run things like Control-C and it won't kick you out, right? Control-C typically is something that stops a command from running. It's like it's called a keyboard interrupt. And when you do that, you can still interact with the program, and it won't kick you out of the thing. So, for example, you create the shell, and if it's not interactive, if you run Control C, it'll actually kick you out of the shell. When it's interactive, you do Control C, and it stops whatever you're running while you're in the shell. I hope that kind of makes sense. This is the example that they have for interactive. So you do SSH, Maria localhost, authenticity can be established, whatever. Are you sure you want to continue connecting? And you say yes. Here you can see that it's asking interactively that the user type either is a yes or no to continue the session. It's an interactive program. Non-interactive, you just do the listener and then it automatically runs it. But then it says who am I command executes perfectly, but the SSH command, which is interactive, gives us no output at all. As an interesting side note, the output of an interactive command does go somewhere, but it just doesn't. You figuring it out is an exercise to try to figure out later by ourselves. Then we have additionally in various places throughout this task, you'll see a command called listener in the screenshots. This is an alias unique to the attacking machine used for demonstrations, and it's a shorthand way of saying that sudo, yada yada yada, netcat listener, which will be covered in another task. So what type of shell connects back to a listening port on your computer? It's a reverse shell. You've injected malicious shellcode into a website. Is the shell you're receiving likely to be interactive? And it's going to be no, because in order for it to be interactive, it actually asks you a question and you are now interacting with the shell. What I gave as a definition earlier, as in a description, was not what they're talking about over here. So I kind of went ahead and I gave more explanation than I needed to give, but it's better for you to know. Then you have you've injected the malicious code into a website. So is what you're receiving to be interactive? Most likely not. When you use a bind shell, would you execute a listener on the attacker or on the target? And so a reverse shell is having the listener on the attacker. Bind shell, the listener is on the target. So just keep those in mind, and as we go further ahead, so that you can kind of, it should connect for the most part. If it doesn't, that's the benefit of having a recording, and you can rewatch this as many times as you want. So now let's talk about Netcat. So let's actually get into some of these tools here. So Netcat, here we go. All right, so Netcat, it's a very basic tool. With it, we can do a lot of things. For example, the reverse shell, as we already talked about. Here's what these flags actually stand for. So L is to tell Netcat that you want to be a listener. V is to create a verbose output. And N tells it not to resolve host names or use DNS. So meaning we are going to be using IP addresses, basically. I guess N stands for name or not. I don't know exactly that, because in my mind I'm like, okay, well, don't use DNS. Maybe we tell it a D flag or something, but I think it's standing for not DNS. That's what N stands for. And then P is indicating that we're going to specify a port after the fact. So that is the general description of these flags. And so we use port 443, and then we can use any port that we want, really. If you use a port below 1024, you'll need to use sudo, which is the root command. And it's often a good idea to use a well-known port, as it's more likely to get around firewall rules on the target. When we use msfvenom or anything like that, we always create ports like 4444 or 5555, something like that, because it doesn't require that we use sudo. But if you can use sudo to do it, then you should, because it's more likely to get around firewall rules on the target. So working example would be using 443, which is HTTPS, the secure connection of HTTP. And then we can connect back to it with a lot of payloads. There's another thing to note here that they have not mentioned, is that if this is already in use, then you can't create a listener. So if the port that you are trying to use is already being used by another service, you can't do it. You can't use it for your Netcat listener. Bind shells on the target, we can assume that there's a listener already waiting for us, and all we got to do is just connect to it. So the syntax is very simple: Netcat, and then the IP of the target, and then the chosen port of the target, and it's really easy. It's very, very simple. No flags or anything necessary. So basic, very, very basic. We're going to be doing this in the next few tasks at the very end, so we'll look at it later. So let's talk about these questions real quick. We got which option tells Netcat to listen, and L. That one's a really easy one. How would you connect to a bind shell on the IP address 10.10.10.11? And that's it, Netcat 10.10.10.11 on 8080. Super simple. It's actually very, very simple. The hardest time that I had with this was when I was going through the first part of this and I was trying to analyze this thing right here, and I was just stuck. I was like, what the hell is this portion right here with the evil WinRM? I'm like, I don't understand. This is the first time, obviously, that I was going through this, and I was just like, what is going on? This doesn't even seem right. But yeah, that's basically it. That's it for Netcat. So let's talk about Netcat stabilization, Netcat shell stabilization. Stabilization, goodness gracious. All right, so we have a shell now. Here's where the control C kills the whole thing. That's what I was talking about earlier. So to stabilize your shell, and I guess actually I was completely incorrect when I was referring to it as being an interactive shell or not. I was actually referring to it being a stabilized shell. So that's my bad. Oh no, I am right. What am I saying? They're non-interactive and often have strange format. Dude, I was right. Okay, never mind. I was right. Never mind. Just scratch that. Um, so this is due to Netcat shells really being processes running inside a terminal rather than being a bona fide terminal in their own right. Fortunately, there are many ways to stabilize Netcat shells on Linux systems. We're going to be looking at 3 different ways here. One of them is Python. So the first thing that you want to do is import pty spawn yada yada yada, which uses Python to spawn a better featured bash shell, and some targets may need the version of Python specified, so Python 2, Python 3, and once you do that, the shell will look a little bit prettier, but we still won't be able to use the tab autocomplete or arrow keys, and Control C will still kill it. So step 2 is to export term equals xterm, and it's going to give us access to the term commands such as clear, and then most importantly, we can background the shell using Control Z, and we're in our own terminal. We're going to use stty raw echo. This does 2 things. First, it turns off the terminal echo, our own terminal echo, which lets us access autocomplete, arrow keys, Control C to kill processes, and then it foregrounds the shell. So it looks like this. The full technique is like this. So you do sudo netcat lvpn lvnp443. So you have a listener. And then once you do that, it's connected. So the connection is done, right? And then you run Python import, so on and so forth. And then the shell is here. So you now have a shell. Once you have the shell, you do export term equals xterm, and then it does that. And then you background it. Control Z is how you background something. And so one thing has been stopped, and then you do the netcat listener command one more time. And then, or excuse me, my bad. It's stopped the original process that we had right here. So it just put this shell in the light blue here, it put it in the background. And then once you've backgrounded it, you run raw echo foreground, and then sudo netcat, so on and so forth. And when you run it now, who am I as shell, Control C still cancels that out. You can do shell SSH shell localhost, and now it gives you the option to be interactive with this thing. And now you have the localhost password, so on and so forth. So if the shell dies, any input in your terminal will not be visible as a result of having disabled the echo terminal. And then you can do reset and press enter. So this was the overview of using Python. So you create the netcat listener, it connects, Python C import, so on and so forth. And then once it'll actually complete that, you're inside the shell, and you can run export term, so on and so forth, and it runs that. Then you background it, and then it says that this has been backgrounded, and then you go back in your original command line, and then you run the stty raw echo, and then foreground your previous shell session, and now you're back in the shell session. Who am I? Shell, Control C, doesn't close it out, doesn't exit your shell session, and you can run an SSH to another shell if you wanted to. So it makes it interactive as well as secure or stabilized, as the name implies. Technique 2 is the RL wrap, and it's a program that gives us access to history, tab, auto-completion, arrow keys immediately upon receiving a shell. However, some manual stabilization still needs to be utilized if you want to use Control C inside the shell. RL wrap is not installed by default, so first we got to install it, sudo apt, and then to use it, we invoke a slightly different listener. So you do RL wrap first, then Netcat listener, so on and so forth. And then prepending it gives us a much more fully featured shell from the get-go without you having to run all of these extra features right here, right? It's particularly useful when we're dealing with Windows shells, which are otherwise notoriously difficult to stabilize. And then we got to keep all of this in mind because we're going to be creating some shells later on, right? So when dealing with a Linux target, it's possible to completely stabilize, but by using the same trick as the in step 3 of the previous technique that we did. So you background the shell with Control Z, then you use this to stabilize and re-enter the shell. Then you have Socat as your third easy way to stabilize the shell, is to just do an initial Netcat shell as a stepping stone into a Socat shell. And this is limited to Linux targets, so the target needs to be Linux, doesn't work on Windows. And Socat shell on Windows is no more stable than Netcat. So to accomplish this, we would need to first transfer a Socat static compiled binary, and it's the version of the program with no dependencies, to the actual target machine. So you need to upload the binary to the target machine first. Then once you achieve this would be basically to achieve this, it would be to run a Python server and to run wget. And you've probably also seen this a lot because we've done this a lot in previous rooms where we had to transfer a payload from our attack box to a victim machine. And for the sake of completeness, in Windows command line, the same can be done with PowerShell using invoke web request or a web request system. So invoke web request is basically the wget version for Windows PowerShell. So you do invoke web request, URI, the IP, and then Socat executable. The out file is going to be where you're going to save it to, and then you kind of run the same thing. So this is what we did right here to transfer it to a Linux machine. This is what you would do to transfer it to a Windows machine. But both of them start with first creating a Python server on your attack box, and then depending on which type of machine you're using, you would just use a different command to download that file from your server. And then when you do that, you basically have a stabilized shell. So with any of the above techniques, it's useful to be able to change your terminal TTY size, time to, I forgot what TTY stands for. Let's see if it tells us. This is something that your terminal will do automatically when using, terminal type. I think that's what that is. I'll have to, let's just verify it. What is TTY in Linux, I guess? Let's see. TTY is teletype. I see. TTY stands for teletype, and it's a terminal in Linux. Okay. This is something that your terminal will do automatically when using a regular shell. However, if it must be done manually in a reverse shell or a bind shell if you want to use something like a text editor, which overwrites everything on the screen. First, we open another terminal and run sttya, and it'll give you a large stream output, and the values for rows and columns is what we need to save here. So we have on our attack box, in our temp file, we created a temp file right here, sttya, and it gives the speed, and then row 45, column 128. And then in the reverse bind shell, we're going to type in stty row and then give it a number, and then stty column and then give it a number, and then filling in the numbers that you got from here, and it should be able to adjust everything and change the registered width and height of the terminal that you're using so that text editors, which rely on information like that, are accurate and they open correctly. So how would you change your terminal size to have 238 columns? Stty calls 238. What is the syntax for setting up a Python web server on port 80? You do sudo python 3 m http. And this, you don't necessarily even need to do this. You don't necessarily need to do a sudo command to create your Python server. I've done it a lot without running sudo, but I guess they kind of want to get us into the habit of doing that. So it's like one of those best practices. So that's it. That's how you stabilize a Netcat listener. But then if you end up using a Socat listener, it kind of already comes stabilized. So let's talk about Socat. Okay, Socat, similar to Netcat. The easiest way that we can think about this, it's a connector between 2 points, as always. There is going to be a listening port in the interest of this room and a keyboard. However, or I guess it says this will essentially be a listening port and a keyboard. However, it could also be a listening port and a file, or indeed two listening ports. All Socat does is provide a link between 2 points, much like the Portal gun for the Portal games. Once again, we're going to start with reverse shell. So Socat, TCP-L, TCP-listen. So the syntax, as you can tell already, is a little bit different. And then you have the port number followed by a dash. It takes 2 points, so a listening port and a standard input, connecting them. The resulting shell is unstable, but this will work on Linux or Windows, and it's equivalent to the Netcat listener command. On Windows, it's a little bit even more complicated. So you have Socat, TCP, the local IP address and the local port, and then you want to execute PowerShell exe on pipes. The pipes option is used to force PowerShell or command line to use a Unix style standard input and output because we're going to be using a Linux machine to connect, and the syntax for PowerShell or Windows in general is very different. So when you want to do ls to list something, you would have to do dir to list something inside of your terminal or command line PowerShell from Microsoft. So they have a different syntax, and so when you do this, it uses a Unix style input and output, which makes it a little bit easier. So this is the equivalent of a command for a Linux target, which is TCP local IP local port, and then execute bash li. And then so this is it for reverse shells right here. And then we have bind shells. So Socat TCP listen port number, and then execute bash li. On Windows, Socat TCP port number, execute bash PowerShell pipes. Or excuse me, not bash PowerShell, PowerShell, and then pipes. We use the pipes to interface between Unix and Windows way of handling input and output in a command line environment. Regardless of the target, we would use this command on the attacking machine to connect to the listener that would be waiting, which would be TCP, target IP, and then the target port, followed by a dash. So if we look at some of the more powerful sources of this, which is the stable Linux reverse shell, it only works on Linux, but it's very, very stable, and that's the whole idea with Socat. This technique is one of the most powerful uses of Socat, which is TCP-L, and then you have the port, and then you have the file, TTY, raw, echo, 0, and what it does, it's broken down into 2 parts. So we're connecting 2 points together. In this case, the points is the listening port and a file, and we're passing in the current TTY as a file and setting the echo to be 0. Which means I believe it's false. It's like it's either a 1 or a 0. So when you do 0, it means echo is false. You don't want it to have echo. This is approximately equivalent to using the background Control-Z and then the whole process that we did with Netcat to create a stabilized shell, with the added bonus of being immediately stable. So from the very beginning when you run it, it's immediately stable, and it has a full TTY so that you don't have to adjust the columns and the rows and stuff. The first listener is going to be connected with any payload. So this is a special listener and it has to be activated with a very specific Socat command, which means that the target must have Socat installed. Most machines don't have Socat installed, so it's possible to upload a pre-compiled binary, which can be done again with the Python server and so on and so forth. So the special command, when you have it installed, is going to be this. So Socat TCP, the IP of the attacking machine, and the IP, the port of the attacking machine, and then you're executing bash, PTY, state, all these different extra things, and then we have to look at it one by one. So this part is standard, and you can understand this part, but it's all these extra flags that we've established at the end. So PTY is a pseudo terminal, part of the stabilization process. STDERR, make sure that all the error messages are shown in the shell. And then this is actually a big deal because usually it doesn't show anything. It would just be kind of like a blank. SIGINT is passing any of the control C commands through to the subprocess, allowing us to kill commands inside the shell without killing the actual shell. And then sets ID creates the process in a new session. Sane stabilizes the terminal, attempting to normalize it. So this is what it would look like here, right? So you do sudo socat TCP listen on port 53, and then you have the file and raw echo 0, right? So you have that connection, and it says who am I? And so on this side, when you run that, you have the sudo rl wrap netcat listener. And so we have the netcat listener. You do the socat TCP on port 53. I think actually, no, this one's done first, my bad. So this one seems to be done first right here. And then you have who am I? I am shell. You do SSH shell add localhost, and it allows you to do this. Listening on 443 connected to this on 47.158. Who am I shell socat 53. So this has actually been done first. So my bad. Yeah, this one's a little bit confusing. So this one's been done first, and it's on port 443. Then it was connected to the machine, and this is now connected here, and it has a listener on port 53. And then you attempt to run Socat from this machine on port 53, execute bash and all the other stuff. And then once you actually connect from here to this one on port 53, now you have a stabilized shell here that allows you to run this. So they ran sudo rl wrap first with netcat connected, and then they have the shell, and now they have Socat TCP connecting to the attacker IP as well as the port number. And this listener right here is on Socat as well on port 53. So this one was done first, then this listener is connecting to this specific Socat command. So that one's a little bit confusing, and they did mention at the very beginning that Socat has more of a complicated syntax, so you can see that it does already. So if at any point a Socat shell is not working correctly, it's well worth increasing the verbosity by adding dd, and it's very useful for experimental purposes, but it's usually necessary. It's not usually necessary for general use. So you can get Socat listener on TCP port 80 by doing TCP L 8080. And that was it for Socat. This one was a little bit more complicated, as you can tell, but through its complication and sophistication, it provides more stability and allows you to have more functionality once you finally connect, instead of having to go through all the steps that we went through with Netcat to finalize the stabilization and get a stable shell. So there is that with Socat, and now let's talk about Socat encrypted shells. Socat encrypted shells come in both bind and reverse types. And encrypted shells can't be spied on unless you have the actual decryption key. That's why it makes them really beneficial. And they usually bypass an IDS as a result, an intrusion detection system. So we covered how to create basic shells with Socat, excuse me. And that syntax is not going to be covered here. But anytime that a TCP is used as a part of a command, it should be replaced with OpenSSL. That's kind of the new version of the syntax that we're going to be using. So previously we were using TCP-L, for example. In this case, we're going to be using OpenSSL. So first we got to create a certificate in order to be able to pull this off. and this will be done on the attack box that we have or on your attacking machine, as long as you have OpenSSL installed. And you run this command and it creates an SSL certificate for you. A 2048-bit, which is right here, 2048 RSA key with a matching certificate. It's self-signed, it's valid for a year, and when you run this, it'll ask you to fill in information about the certificate, and you can just leave it blank or fill it with whatever you want. Then you merge the two created files into a single .pem file by doing cat shell key and shell cert into the shell.pem file. And now you have a complete certificate, SSL certificate. Then you have the Socat listener now. And so instead of doing TCP/L, now you're doing Socat OpenSSL listen, and then on the port that you have, and then you have your certification equals the PEM file that you just created, and verify is false, meaning you don't want it to verify, and then you just do your dash at the very end. This command right here opens the OpenSSL listener using the certificate that we have. Verify tells the connection not to bother trying to validate the certificate. Please note that the certificate must be used on whichever device is listening, meaning the attack box in this case. And so to connect back to it, we would use Socat OpenSSL, the IP address of the attack box, the port that we're listening on, verify 0, and execute a bash shell. And the same technique would apply to a target shell. So on the target machine, you would run Socat OpenSSL listen, the port number, the shell PEM file as your certificate. You don't need to verify it. You're going to execute a command with pipes so that it becomes Unix compatible. And then you have Socat on the attack box. You have Socat OpenSSL, the target IP, which is the target machine's IP address, on the port that the machine is listening on, and then verify 0, etc. So for even for a Windows target, the certificate must be used with the listener, so copying the PEM file across is required. So you got to do a Python server and then download it, etc., etc. And this is what it looks like as far as the overall process is concerned. So first on the left side here, let's see if we zoom in a little bit, it might be easier. First on the left side here, they've created the certificate. So they ran that command, they created the certificate, this is what it looks like. And then they catted the key and the certificate into a PEM file. And then they ran sudo socat open SSL listen on port 53 using that PEM file. And then on this side, they ran the connection itself. So listener implies that they ran the Netcat listener on port 443. It was connected, and then they were able to run the bin shell right here. So once it was connected, they inside of the bin shell, they ran who am I, and it said that this is who you are. And then they ran Socat OpenSSL to connect to this thing right here, this whole thing right here. And they were able to run that same thing on port 53. They skipped verification and they executed a bin bash shell, which ended up connecting them to this right here. So when you run this piece right here, that was the last piece up here that connected to this, and who am I www data, who am I www data, and an ID, so on and so forth, IP address, so on and so forth. That is what that looks like when you want to do an encrypted shell with OpenSSL. And if we go down here, now it says, what's the syntax for setting up an OpenSSL listener using the TTY technique from the previous task using port 53 and a PEM file called encrypt.pem. So you do Socat OpenSSL listen on port 53. Your cert is going to be encrypt.pem. Verify is 0, so you want to skip verification. The file, so this is the part from the previous thing that we are just adding to using the TTY technique from the previous tasks. Your file is going to be the TTY file, raw, echo 0. So you don't want to create echo either. So basically it's a 1 and a 0 when it comes down to these parameters here. Verify 0 means don't verify. Echo 0 means don't use echo or don't echo. And so this is the full command that you would use in this case for setting up an OpenSSL listener using the TTY technique. And then if your IP is 10.10.10.5, what would you use to connect back to the listener up here? So you do Socat OpenSSL, no listen necessary, and then you do the 10.10.10.5 on port 53, verify, skip that. You're going to execute bash li and then pty stder sigint set sid and sane, all of these parameters that were previously outlined at the very top of this thing in this one right here, where we ran that whole thing, and then we had the special command to have a Socat listener or a Socat binding shell go out and PTY, all that stuff. So allocate sudo terminal, stder, make sure that any error messages are shown, sigint makes it so that any Control-C commands go through this, allowing us to kill commands, set SID creates the process in a new session, and then this tries to normalize and stabilize the shell itself. So that is it for Socat encrypted shells. And now we can go into common shell payloads that can be used in this particular case. I think we're going to be using, well, let me not skip ahead. So let's start from the very beginning. Common shell payloads. So most payloads that we've created or I've created before have been with msfvenom, but there are other ways that we can create payloads. In a previous task, we talked about using Netcat listener for a bind shell, so we can use Netcat listener to create some payloads. And nc.exe is what's available on Windows, and it's also included inside the Windows machine that we're at. Or excuse me, this is actually the binary folder for the Linux machine, the attack box machine. And then it would be Netcat traditional, I guess, which is inside this specific folder. Then there's an E option, which allows you to execute the process on connection. So for example, Netcat, this, and then the port number, execute bin bash, which is you want to execute a bash shell. Connecting to the above listener with Netcat would give you a bind shell on that target. So for a reverse shell, it would be Netcat, the local IP, the port number, and then execute bin bash, and it would get you a reverse shell on the target. So it's not included in most versions of Netcat, as it's widely seen to be very insecure, right? So on Windows, because there is a static binary always required, the technique works really well. On Linux, we would need to use this particular code to create a bind shell, which is mkfifo, and then inside the temp file, you create a new folder called f, and then you create your Netcat listener on this port, and then you're using the temp file folder that you just created, and you pipe that into the shell. So this right here is that entire full command, and then again use the temp file to this, and one skips most error messages. Sorry, I kind of rubbed against the microphone. And then you're going to remove this at the very end. So this is like a series of commands. And so this is the technical explanation for what we just ran right here. The command first creates a named pipe at temp folder F. Then it starts a Netcat listener and connects the input of the listener to the output of the named pipe. So we have the Netcat listener, and then we connect this to the named pipe. The output of the Netcat listener then gets piped directly into shell, which is this right here. So the output of that gets directly sent into the shell, and then sending the std error output stream into std out, and sending std out into the input of the named file, thus completing the circle. It sounds complicated for somebody that has never dealt with shells before, and even for me, as I read through it, it's like, what talked about? So this is kind of what it looks like, just so you can see what's going on. So you have, who am I? Murray. Murray creates the Netcat listener on port 8080, and then this on shell, they create the payload using make FIFO is what I call it, and then they just ran this entire command right here all the way to the end, and now it's listening on any of these things. And so since this person is listening, this netcat command to connect on that IP address on port 8080 works, and now you become shell. So this one on the right side created their listener, and then on this side we just use netcat to create a binding shell, and we connect it to it. Very similar could be to do a reverse shell in this case. So on this side, the attacker is now doing the listening, and then you do make FIFO to create your binding shell on port 443, and then repeat the same process on that at the end of that, and it gives you the shell on this side. And this is just a payload version of the shells that we just created. When targeting a modern Windows server, it's very common to require a PowerShell reverse shell, and we'll be covering the standard one-liner PowerShell reverse shell here. And this is a one-liner right here. And this thing, it goes, I wonder how far, I think this whole thing is the one-liner. So this entire thing is one line. And so we need to replace IP and port with the appropriate IP and port that we want to be connecting to, and then we can copy this inside the command shell or something else to run a command, such as a web shell, and then you execute that, resulting in a reverse shell. So, you know, you have on the attack box right here, you have your netcat listener, and who am I? I'm the admin, so on and so forth. And then on the remote machine, on the Windows machine, you run this entire command. So from PowerShell all the way down here, you run this entire command, and then it gives you your connection to the netcat listener on this side, and now you have that. So there are a lot of reverse shell payloads on the Payloads All Things, which was the repository that we looked at already at the beginning of this room. So we can find a lot of stuff for that, for different types of operating systems and languages and shit like that. So what command can be used to create a named pipe in Linux, which is mk-FIFO, make FIFO. And then we're going to go through the Payloads All Things reverse shell cheat sheet and familiarize yourself with the languages available, because we're going to be using that in a little bit, and we already did that. So I would recommend that you go to the Payloads All Things GitHub repository by Swiss key repo, however you want to pronounce that. It's Swiss key is what it looks like. So this is their username. So Swiss key repo is where the Payload All Things repository exists. So go through that and familiarize yourself with all of these languages that are available here. And from that, we'll be using those things for future reference in the rest of our tasks here. So let's go into msfvenom now. msfvenom, the one-stop shop for all things payload related. So we've used this a lot. So you can create executables, ASPX, .war, .python, a lot of these types of payloads. And you can even list the payloads options by doing list payloads. I think that's actually one of the commands that exists. So this one in particular creates a Windows x64 reverse shell payload, and then it's a function of executable. The output is going to be shell.exe, and the listening host is going to be the attack box IP address, and the listening port is going to be the port that you want to listen on. So the full command looks like this. So you have msfvenom, Windows da-da-da-da, and then lhost is going to be the IP. Lport is 443 on port 443. So that's what that looks like. It takes a few seconds, maybe 10, 20 seconds, and then it saves it inside whatever directory you're in. It saves it as the output file. So F is for the format, which in this case is going to be an executable. The O is the output file, the output location and the name of it. Lhost we already mentioned, and lport we already mentioned. So when you use TryHackMe, they already show you what your IP address is on the very right corner. But if you don't know what it is, or if you use the VPN to connect to the TryHackMe machine, you need to find that by doing IP add show, I believe. And then you can do, it'll show all the IP addresses that you have on your interface. And then you can find the one that's connected to TryHackMe, or the dedicated IP address, which in this case it just says it's the TUN0, TUN0 IP address. And that's pretty much it. So you have staged versus stageless payloads. Staged payloads are sent in two parts. The first part is called the stager, and is the piece of code that executes directly on the server. It connects back to a listener, but doesn't actually contain a reverse shell. Instead, it connects to the listener and uses the connection to load the real payload and executing it and preventing it from touching the disk where it would be caught by traditional antivirus solutions. So it's supposed to be stealthy, or it tries to be stealthy. So the payload, because of that, the payload is split into two parts. The first one is an initial stager, and then the bulkier reverse shell is downloaded when the stager is actually activated. And stage payloads require a special listener. Usually Metasploit multi-handler ends up being the listener, and it's going to be in the next task that we talked about. Stageless is what's more common, and these things seem to be what we've been using this entire time. So they're self-contained, and it's just in that one piece of code, and it executes, and then it sends back a reverse shell, or it sends a shell back, so on and so forth. Staged payloads, I believe, is what msfvenom creates for us, and I'm gonna kind of hold that until we can verify that, but I believe that's what happens, because you create something first and then you send that as the payload, and then that connects back. Stageless is what we've been doing. You just do a netcat listener, and then, or I'm highlighting this, but basically you just do a netcat listener, and then you go and create a bind shell from the other side, and that's basically your stageless payload. So stageless payloads tend to be easier to use and catch. However, they're also bulkier and are easier for antivirus or intrusion protection to discover and remove. So staged payloads are harder to use, but the initial stager is a lot shorter, and it's sometimes missed by antivirus software. Modern day antivirus solutions will also make use of the anti-malware scan interface to detect the payload as it's loaded to memory by the stager. So it's not a full bulky file. It goes inside the RAM, but it can still be detected, and making staged payloads less effective than they would once they've been in this area. So Meterpreter is something else that we've already created a video for. I did an entire video on Meterpreter, and I think that's going to be up by the time that this video comes up, so you can go check that out if you want. Something that Meterpreter does is it's from Metasploit's fully featured shells, and it acts as an agent and allows you to use everything that's on your victim machine as well as everything that's inside of the MSF console. It is really good for working with Windows targets. So far everything that I've done with Meterpreter has been on a Windows target, and it also makes the language very inherent to Linux. So even though you're on a Windows target, you can run something like ls to list the stuff that's inside your directories, and ls is a Linux command. Windows uses dir to list things. So it's pretty useful when you're trying to connect to a Windows machine, and obviously it gives you all the stuff that's available, which is inbuilt functionality, such as the file uploads and downloads and all of the stuff that already exists inside Metasploit. So if we want to use Metasploit's post-exploitation tools, then Meterpreter works, meaning like hash dump and all these other things. They said this is a topic for another time, but this is literally the topic that we discussed in the Meterpreter video, and you can go and check that out, and it's very, very cool, and it's very, very useful. So the downside to Meterpreter is that they must be caught in Metasploit, and I don't exactly know what that means. They must be caught in Metasploit. I'm not sure what that means. Payload naming conventions. So when working with msfvenom, it's important to understand how the naming system works. So the OS, the operating system, the arch, and then the payload name. For example, Linux, the arch would be the version, so x86, and then the name itself. You can also just do list payloads when you go inside of msfvenom, or you can do msfvenom list payloads, and it'll just show you what the names of the payloads are, so you can kind of understand how the syntax of all those things work. The exception to this is a Windows 32-bit target, and there is no arch specified because it just is the lowest version of Windows, so it's just Windows and then shell reverse TCP. But if there's a Windows x64, you would do Windows/x64 shell reverse TCP right here. Right here, it literally just says it. So we're going to break down the payload section even more here. So the payload that was used right here is the shell reverse TCP, and it's a stageless payload. Stageless payload are detonated with the underscores. The staged equivalent to this would be shell and then reverse TCP. Staged payloads are denoted with another /, and this is just a common syntax preference and choice within Metasploit, msfvenom, interpreter, etc. This also applies to interpreter payloads, which means Windows x64 interpreter and then reverse TCP, and that would be a staged interpreter payload, which means it includes a initial stager and then it follows up with the connector. Linux 32-bit stageless payload would look like this: Linux 86 interpreter, and this is what stageless, because interpreter is connected via an underscore to the reverse TCP part. Aside from MSF console manual page, there's another thing that we can figure out about this is the list payloads, which is what I just talked about. So you could do msfvenom list payloads, which means you don't have to go inside of the MSF console to list all the payloads. You could just do msfvenom list payloads, and notice how the command line name right here is still Murray, Augrey, or whatever, and it's listing everything. When you go inside MSF console, this changes Murray Augrey into MSF6, and that becomes the intro to your command line, and then you would have to do list payloads, so on and so forth. So generate a stage reverse shell for 64 Windows in an exe format using TryHackMe tune IP and a chosen port. What is symbol? So this is going to be something that we're going to do later. I don't know why they did this right now, but which symbol is used to show that a stage is a shell is stageless, and that's the underscore, because it's connecting everything together, and if it's staged, it separates it by a /. What command would you use to generate a staged interpreter reverse shell for 64-bit Linux target, assuming that your own IP was this and you're listening on port 443? So msfvenom p Linux x64 interpreter reverse TCP. So again, staged, so you're separated by interpreter / reverse TCP. If it was stageless, it would be interpreter underscore reverse TCP. And then it's in the ELF format. The output is going to be shell, and the listening host is the IP that they gave us, and the port is on port 443. And just to kind of look at this thing, the command that they want us to run over here, I think they actually give us the command. It says it's covered in the task. All you need to do is substitute your own tune address and the chosen port, which is basically the thing that we saw at the top right here. This piece right here. Windows x64 shell reverse TCP, so on and so forth. So that was it for msfvenom. So now let's jump into the Metasploit multi-handler, which is another shell. Multi-handler is a cool tool for catching reverse shells. If you want to use interpreter, it's really good when you understand. It's kind of like the go-to for staged payloads, which means they have an initial stager. It's pretty easy. So you open Metasploit, going to MSF console, and then you use multi-handler, and then you press enter, and that's it. So you do use multi-handler, and so you see right here, MSF, this is the MSF version 5, and then it changes your command line into exploit multi-handler, and then that little greater than symbol means that this is your entire command line right here. And then you type options, and it shows you all the options for your multi-handler. And anything that's required is what you got to set up. And the L host is our IP address as the listener. And so you just put your IP address for your listener, for your attack box or your Kali Linux, whatever it is. And that's pretty much it. That's all you got to do to set it up. Then you can choose the payload that you want. So there are 3 options that we need to set, which is the payload, L host, L port. If you don't set the payload, it already comes with the generic one that says already chosen, which is generic shell reverse TCP. These 3 are identical to the options that we set when we generate a shell code with msfvenom. We have to create a payload as well as a listening address and a port. So it's all the same, except now we're just doing it inside of MSF console. And the L host has to be specified because it's required. So all of this we already talked about. So you can set anything by using the set command, and you can unset something by using unset. So you can do set payload, name of the payload, set lhost, the IP address, unset lhost, and it just removes the IP address. You don't need to put anything after that. So if you just say unset lhost, it'll just remove whatever you put as that value originally. And so now you can do, using the exploit j command, to launch the module running as a job in the background. If you don't include j, it just runs it and it actually launches it inside what your current shell is. So for this case, they did that, and then it completed, but no session was created because it's in the background. And then it says started reverse TCP handler on the IP address and the port number. Metasploit is listening on a port under 1024. To do this, Metasploit must be run with sudo permissions. It doesn't show us that they ran it originally with sudo. Oh, it did right here. Sudo msf console, and they ran it with sudo permissions in order to be able to run it on a port under 1024. And when the stage payload generated in the previous task is run, Metasploit receives the connection, sending the remainder of the payload and giving us a reverse shell, which says right here, it automatically does it, and you're already in there. And as you can tell, users administrator simply just implies that it is a Windows machine, because everything inside Linux, it says root, and you don't, I mean, yeah, admin, that's kind of how I differentiate it, is that if it says administrator, that means I'm inside a Windows machine. If it says root, that means I'm inside a Linux machine. There's also the idea, this distinct difference that in a Windows machine, there are no forward slashes. It's all backslashes. In a Linux machine, it's a forward slash. So right here, you see how this is multi forward slash handler. Right here, it's C backslash users. That's another key. And then, of course, C in itself is something that is inherent to Windows. So because the multi-handler was originally backgrounded, we needed to use session 1 to foreground it again, which is what they did right here, because they originally ran it in the background by using -j. So that's why it feels kind of redundant, like you're doing extra work by running it in the background, unless you're going to do something that requires you to set a session, which is what Metasploit has. Metasploit has a lot of different exploits that you can use, and some of them require that you have a backgrounded session, and then you activate that exploit, and then in the options of the exploit, right here where it says that, you know, the lhost and the lport is required, on certain exploits it says the session is required. So you need to have a backgrounded session, and then you assign that session to the new exploit that you're using, and then that way you can run any other exploit. So this works the only session running. There's been other sessions active. You would have to use this, yada, yada, yada. So we've already talked about that. So what command will be used to do a listener in the background with Metasploit? It's going to be exploit-j. And if we had just received the 10th reverse shell, what session would be used? So it would be session 10, just like that. So now we are going to move on to the web shells, which is another category of shells altogether. There are times that we're going to encounter websites that allow us to upload things, and in some way or another, those things could be an executable file. So it could be PHP or ASP, and a lot of times those things could be a reverse shell or a shell file, so on and so forth. So you can upload a web shell, and upload vulnerabilities room. I don't think I've done a video on this. I know I've completed this room. Yeah, I have. I have completed this room. I will definitely do a video on this room because it's actually very, very cool, because you can upload things into websites, including web shells, which means now you can access everything that's on that web server and basically do a lot of neat things, very similar to what you would do if you had a reverse shell on somebody else's computer. Web shell is a colloquial term for a script that runs inside a web server, usually in PHP and ASP, and executes code on that server. You can essentially run basically commands on that through either HTML or direct arguments inside the actual URL itself, and then that gets executed by the script that you've uploaded, and results returned and written onto the page itself. So like this is what it looks like. So in a basic one-line format, this is a PHP echo shell execute get command line, and this entire thing ends up being that PHP command. And this will take a get parameter in the URL and execute it on the system with shell execute. And essentially what it does is that everything after cmd will be executed on the system as a command, whether it's Windows, Linux, doesn't really matter. The pre-elements ensure that the formatted correctly on the page. So this is what it looks like. You have the IP address, uploads, and then this is what we've uploaded is the shell.php, and then after that this question mark appends everything back on top of this shell.php, and the command equals ifconfig means that it's going to show us the IP addresses that are associated with that web server. When we navigate the shell, we use a get parameter with command followed with the ifconfig, which we already talked about. So anything that you do after that command, for example, who am I, hostname, arch, all that stuff just gets printed onto the screen. And there are a lot of different types of things that are available inside our attack box. They're all under Webshells, but then you can just go to the Pentest Monkey PHP reverse shell or Pentest Monkey GitHub repository and find all the different reverse shells. But you can also just search on GitHub to find a bunch of different web shells that are available and in a variety of different languages, because some websites don't do PHP, they do Java. So there's a lot of stuff that you could use instead of PHP shells. When the target is Windows, it's a lot of times easier to obtain RCE, remote code execution, using a web shell by using msfvenom to create a reverse shell or a bind shell in whatever the language of that server is. Obtaining RCE is often done with a URL encoded PowerShell reverse shell. This is going to be copied into the URL as the command argument. This is much more complicated, as you can tell. It's a different level of complication, and I hate these things. It's something that I have to kind of learn how to embrace and practice more, but I really can't stand this type of stuff because this looks like jargon to me, and I know that it's not, because if you remove the percentage signs, a lot of things start making sense. And you have the IP address that you still need to put, you have the port that you still need to put, and it creates a variety of different things. And this whole thing is one fucking thing, but it's very, very annoying. So this is the same shell that we encountered in the last task or a few tasks ago, but now it's URL encoded to use safely in a get parameter, and the IPN port, which is right here, still need to be changed to actually make this work. So this is it, and URL encoding of commands can be done through something like CyberChef. So you take the command and then you put it inside CyberChef, and then you request, you use the thing that URL encodes it. So for example, if we just went to CyberChef real quick, we can go right here, and anything that we paste into here could be so if I do PowerShell.exe, for example, and if I do URL encode, so let me just type in URL encode and URL encode like that, you drop that, and I mean it's still PowerShell.exe, so PowerShell.exe space, there you go, that's all I had to do, PowerShell.exe space, and now it's encoded. So space is %20. That's what space is in URL encoding. And if I do PowerShell.exe and then do get AD, get Active Directory user space, and then do format everything, that's what this looks like, right? So that command up there looks like this. Or not format, actually. Format is not a thing. It's filter, excuse me. So whatever, it doesn't matter. You see the difference right here. And now we can move on to some of our next steps, which includes the practice questions. So let's see what we got to do here. So now that we have a reverse shell, there are some things that you can do after the fact. So uh, in Unix shells, it's easier to stabilize things, or Unix style shells, it's easier to stabilize things, but it's not the ideal situation. And stabilization is really the big issue here. So what we could do is to find opportunities in both types of environments to make it a little bit easier and to make it more efficient and productive. So in Linux, if you want to get access to a user account, SSH keys are included inside of the home and then the name of the user, and then there's something called .ssh, but it's usually hidden. And then I'll show you what there's a lot of different videos that have already done this, but it's basically ls dash la, and then it lists everything inside of that directory, including the hidden files. And so when you do that, you can see the .ssh file, and this stores the SSH keys for that user, right? In CTFs, it's not infrequent to find credentials lying around somewhere on the box. Some exploits will actually allow us to add our own account, and in particular something like Dirty Cow, which is a program that kind of allows you to run things within a web server, or any kind of writable etc shadow file, which includes all the password hashes, or etc password, which includes all the usernames. etc shadow also includes all the usernames, but it's usually not accessible. So first you need to find the usernames from etc password, and then use that to find the information on etc shadow. Any of those information will give you SSH really quickly, and obviously assuming that SSH is open, and SSH is a secure shell connection, which is just it's a lot more useful compared to a reverse shell, for example. On Windows, the options are a lot more limited. Sometimes it's possible to find passwords in the registry. VNC servers, for example, frequently leave passwords in their registry in plain text. Some versions of FileZilla FTP also leave stuff in an XML file included in this directory specifically, or in the XAMPP FileZilla directory. And these can be MD5 hashes or NTLM hashes, and you can just use those to reverse engineer what the passwords are. Ideally on Windows, we would obtain a shell running as the system user, or an admin account running with high privileges. In a situation like that, it's possible to add our own account in the admin group to the machine, and then log in over the RDP, because typically if you logged in over RDP as an admin, it shows up as a notable event in the Windows events or in the antivirus, and it flags. But if you create a user and then log in with that user, then it doesn't show up as big of a red flag, or not even really that big of a deal, right? So log in over any of these protocols, and you can do whatever you want at that point. The syntax would be net user, meaning to add a user. This would be the username and the password, and then you add them, and then add to the local group the username that you just made. The important takeaway from this is that reverse and bind shells are an essential technique to gain remote access, but they will never be as fully featured as a native shell. So we always want to escalate into using a normal method for accessing the machine, and this is invariably easier to use for further exploitation of the target. So reverse shells and bind shells are all good, but if you can secure shell into it, or if you can RDP into it, it's even better. And these are the things that you need to understand, is that stabilization is the big key here. So getting a reverse shell to be able to transfer something into the machine to give you a more stable shell, that's kind of the big goal in the end of all this stuff. So, okay, so here are our practice questions, and these things directly apply to these machines right here. So as you can tell, the machines themselves don't have anything to do or to answer really. They just kind of give you the log, not kind of, but they give you the login information for the machine if you wanted to RDP into it or anything like that. So I'm going to start this one, and it's going to give us our victim machine IP address that we're going to end up using for these tasks right here. and I think it goes, yeah, so there it goes from up here and it goes all the way here, and this is all to do with the Linux machine, and then all of these from here are going to be for the Windows machine. So we're just gonna start from the very top, and we're gonna run these exercises one by one. And I mean, you know, so upload a web shell to the Linux box, and then use this to send a reverse shell back to it. And then we're going to navigate to this thing to change the IP address, and we're going to use this PHP reverse shell as a web shell to do it, and set up a Netcat listener, Linux machine over SSH using credentials, and then use the techniques in task 8 to experiment with bind and reverse shells, practice reverse bind shells, so on and so forth. So we're just going to run through all of these exercises, and then we're going to run through the Windows exercises. So I have already started the attack box, so that should already be loaded. Let's make sure it is. And let's just close some of these extra windows here. And so here's our attack box. I'm just going to open this up in a full screen to make it much easier to use, and it will minimize this one. And I also have these list of questions open in a completely separate window on my secondary monitor, so it makes it a little bit easier to navigate back and forth. But basically, I mean, we're just going to go one by one, and we're just going to run all these exercises. So let's see. Yeah, our victim machine IP address is also up. So now we get to have some fun. So the first one is saying just try uploading a web shell to the Linux box, and use the command netcat local IP yada 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 to send the reverse shell back to a waiting listener. So this means that we're going to be doing this inside of the web shell, I believe. Try uploading a web shell to, So let's do that one first. So here's our machine. We're going to open up a terminal, and we're going to open up our browser. All right, so the web portal is going to be at this IP address. So if we go here, we should get something that we can upload something into. So let's go here, and there it is. So file uploads, and we can browse and upload something. So before we do that, we need to actually go find the web shell. And let me see, am I zoomed in already? It seems like I am. Okay, so I'll just move this here. And the address of the web shell, based on what they gave us, whoops, super zoomed in, this is where the web shell is. So we're going to go to that address, and we're going to try to find the web shell that we're supposed to edit. So it's share Webshells PHP. So let's just go in here first. I think it's either, cd user share. There we go. Yeah, okay. And then cd Webshells, and then cd PHP, and then we ls, and there's the reverse shell PHP. So I'm gonna use it. I'm gonna use nano to open it, and this is the shell. This is the PHP code for the shell, and we need to go over here and change the IP address, which is going to be our attack box IP address, which for us, it's literally in the top right corner. This is it. So 10.10.164.207. That's what I need to change this part to. So let's do that real quick. And then any port really, so I could leave it on 1, 2, 3, 4, and whatever. I'll just do 4444. That's fine. So 4444, and that's basically it. That's the only thing that we need to change in this to match our, the important part is the IP address. So I'm just going to do Control O and save that. So you press enter to save that, and then you do Control X and you X out of that. So now we have our reverse, we have our reverse shell file. So we're going to go browse here, and then I need to go find it, which is inside, no, not inside root. Probably go back some more. Right here, there we go. So it's going to be inside user and inside share. I should have saved it on my desktop. It's going to be user inside share, and then we're going to go all the way to W. So all right, I'm going to go find this real quick. Webshells. All right, there we go. That's our reverse shell. So we're going to upload this thing. And there it is. And before I submit, I'm just going to create my Netcat listener. I think that's what I need to do specifically. Yeah, so I'm going to go first, submit my, or I'm going to create a new, or I think I can do it inside my same one right here. So we're going to set up a Netcat listener real quick, and we'll do on the same port that we had before. So it's going to be Netcat LVNP as we saw already, and it's going to be 4444, and that's the command. So I mean, very, very straightforward. So we're going to enter that, and there's our listener. And now I'm going to click submit on my upload, and it says that this has been uploaded into this section. So if I click on this, nothing's going to happen. If I go into here, it says I have a reverse shell. Look at that. I already have my shell. So I didn't even need to do anything. And I have my reverse shell. So if I do ls, there's the thing. If I do who am I, it says www data. If I do print working directory, I'm inside the root directory. And I can go cd user, and I'll be inside the user directory. I'll do ls here, and it'll be cd share ls cd. Do we have web shells here? We don't have web shells here. So that's how I know that we're now inside the web browser, because when we went to share, so that we're now inside the user share folder. So let me kind of zoom in here a little bit for you. So we're inside the user share folder of the web browser, of the web server, excuse me. And from here, now we can see what's inside of the share folder. And for us, in our machine, there was something called Webshells. So you see that there's nothing here called Webshells. So that's another way that you can verify that you're inside the shared folder. But I can literally just go here and do a print working directory, which is the same thing, or just do the who am I, right? So who am I says I am www.data, and then if I just open up a new terminal and do who am I, it says I am root. I am Groot, I am root. So that's it. So now we have our, and that was super simple, very, very basic. So that was one version of this. But then there's another version of this that we can run, which is by doing an execution of the command prompt. So we can do something else instead of just clicking on the uploads of the web shell, because we can even run this at the end of our command prompt. So for example, so if I stop this from running and then go here, so here's another version of this, right? So instead of clicking on this uploads link, I went up here, PHP reverse shell, and then question mark command equals netcat, and I put a space so you can see that it's been URL encoded. So space is the percentage 20. So I put netcat space, and then this is the IP address of my, oops, damn it. That was not what I was trying to do. Let's see if I can go back. God darn it. But basically, so this is the command. I'll type it in again so you can see what I did. This was the command. So the full command is php reverse shell .php, and then cmd equals nc, meaning netcat, and then we're trying to connect to our attack box IP 4444, yada yada yada, and that was it. And we just used that, and then I pressed enter on that, and that gave me my reverse shell here one more time. And I mean, they both work. So if I do who am I, same thing, right? So that's another version that we were able to get our reverse shell or a web shell. There's something else that we could also do. So I feel like I can use even a different web shell. So instead of the web shell that was already here, the PHP reverse shell, which I think is something that already came pre-installed, I'm gonna go try to find another web shell, and I'm gonna do that inside of this thing right here. and we're going to go in the web shells that are available. Let's see, there should be a link right here. So we can use one of these web shells right here. This I think is actually one of them. So this is the most common side. We're going to a simple code for a server-side scripting web shell. So I took that code and I'm going to create one right here, and I'm literally just pasting the code that's here, this thing. I'm just taking this thing and I'm going to paste it here, and I'm saving it as shell.php. And now this is going to be inside of my root folder here. And so I'll go here, because I think what I did, even though that this technically I put the command at the end of it and it worked and it did that for me, I'm just going to copy this command real quick, and we're going to use a different port number ultimately. But I'm going to put this at the end of another shell file that we have now. So if I go back to desktop or root, and there's my shell file. So I'm going to upload this shell file and submit this, and it's going to be inside uploads shell.php. So if I go to uploads shell.php, because you saw that that shell file doesn't have any IP address or port number inside it. The first one that we did, we actually added the IP address and the port number inside the script itself, but this script has nothing like that. So what it's going to allow us to do is do the command at the end of this, right? Command equals ifconfig. So instead of this, now what we're going to do is we're going to do the uploads / shell.php, and then do the question mark to append this at the end of it, and the command is going to be our netcat command right here. And I have command pasted twice, so we're going to delete that. And then I'm just going to change this to 4443, right? So now we'll open our prompt back up. We're going to cancel out of this one, and I'm going to do another netcat shell, or netcat listener. This time I'm going to listen on 4443 just to make sure that that's different. And then we're going to go here and we're going to press enter on this one. And now this one, connection received. Look, connection received from yada yada yada. So we actually received our shell, and if I do who am I, it says www data. But notice how this is different from this. You see how this one gave us this $, and it can, I mean, in the same way, it still shows print working directory. I'm inside my var www.html uploads directory, because that's where I uploaded the shell, you see. So this is a different instance as what we had originally, because the last one, when we loaded it, it put us in the root directory and it was a completely different shell. This one is the basic shell and it puts us exactly inside the uploads directory. And if I do ls here, it shows me the two shells that I've already uploaded, the PHP reverse shell and the shell.php. So we have both of our shells here. So now I can just go back, you know, to the original home folder, which is going to be var. So one more, and now I'm here and I can do ls and it shows me everything again. And I can go to cd user and do ls and it shows me everything inside the user folder. So it works. Both of them work, except this one just doesn't give us that $, to kind of make it a little bit more secure, I guess. I don't want to say it's secure, but maybe stable might be the right word. But still works. You can see that it still works and we still got the result that we wanted. So now we've uploaded two different types of shells into our command. So let's see, what do we got? We got the first one, which was just a basic one, and then we appended this at the end of our command line inside the browser, and right at the end of our shell file. We also did this one, that was our reverse shell, so we did that one as well. Now we're going to log into the Linux machine using SSH, and then we're going to use one of the techniques in task 8 to find a bind and reverse shell. So I'm going to close out of this one, and that thing is now loaded in, or finally loaded in the background, but it gives us nothing, so it's irrelevant. So now we are going to go to the main folder that we were originally in, which is this thing, and now I'm going to SSH into the username and password that they gave us here, which is shell, and then I'll just copy this for my password. So I'll do SSH. What's going on? Let me type SSH. Dude, why isn't it letting me type? That one lets me type. This one's weird. Why isn't it letting me type? We'll just close that out. So we're gonna do SSH shell at what is the IP address of the victim? 10.10.196.116, and enter on that. And yes, I want to continue, and I'm gonna paste this in here, and that should be fine. Are you gonna let me paste or no? Paste. There you go. Bro, what do you mean? That is obnoxious. I hate it when this happens. Okay, fine. I will manually type this stupid thing. So try hack me. What? That's annoying. 10.10.196.116, right? Isn't that it? Let's see if that's the right IP address. Maybe I'm using the wrong IP address. 10.10.196.116. That is the right IP address. So why is it incorrect? So let me see. Okay, there you go. Whatever, that was weird. So now we are SSH'd inside of our machine here, inside of our Linux box. I keep saying Linux. So now we're going to use some of these examples here. So we can do the make FIFO to create one, and we can, I'm definitely not doing the PowerShell one because that's for Microsoft. That shit looks insane. Okay, so we're going to do the make FIFO one to connect from our victim machine back to our attack box. So let's do that. All right, the first one that we're going to try is to put the make FIFO inside the SSH shell right here. So we're going to start the Netcat listener from our side, from the attack box, or not the Netcat listener. We're going to do a bind shell from our side by using Netcat, and then we're going to have our listener set up on the victim machine using this command right here. So I'm just going to take this command, I'm just going to copy it to make life easy, and we're going to paste this here. And what I need to do is I need to change the port number that we're going to be listening on, because there is no port here. So we're going to go right here, and we're going to change the port here. We'll do 3333 this time. And so now we have a Netcat listener on our machine right here. So I'm just going to start this, and this is going to be this is the one that we SSH'd into, right? So this is our victim machine, which means that now we need to go into our machine, our root box right here. And then from here, we're just going to do a Netcat on this IP address on the port 3333. So Netcat 10.10.196.116, and then 3333, enter, and just like that, it connected to this thing. And so this should already be done. So if I do ls, it says it's connected. So let me see if it's done or not. Oh no, you know what? I think what I need to do is I need to stabilize this, I think. So let's see if we can stabilize it or not. So I'm going to do the Python command, Python 3. Okay, there you go, that worked. Oh no, it didn't work. It says too many output retries and our connection broke. So I think that didn't work. So if I run this, yeah, it's not going to work. Let's see. Let's try to troubleshoot this. Well, it's kind of odd because it actually connected. It just wasn't allowing us to do anything on the other side. So I'm going to run this one more time. Make FIFO, yada, 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 port 3333. And we'll do that. Now it's listening. And we're going to run the Netcat one more time on our victim, and it says connected. So connection is done. All right, so let me see if that's the listen. Yeah, connect to, so on and so forth, is done. So we actually have our connection. So let me see, who am I? Oh, there we go. Okay, it did work. So I wonder why the ls command originally didn't work. I guess because it was empty or something. So print working directory, home shell. Okay, no, it did work. It did work the first time. I guess there was nothing inside of the home shell directory. So if I go back one and do print working directory, I would be in home. If I do ls here, yeah, okay, that does work. And if I went back one more and I do ls here, got it. So it does work. That was great. So it worked. And now we are good with this one. And let's try to do the other version of this. So I'm going to cancel that out. And this one is done. So the first version was that we put the listener on the victim machine. So now I'm going to do this version where we put the listener on our attack box and we create the full thing, or the outgoing message, the outgoing Netcat. Do I have to type this out because I can't paste it? I guess I'll type it out. So let's open this up on the secondary monitor. So this is gonna what it's gonna look like on this thing. So it's gonna be make FIFO. Alright, so that's the command, and this is gonna be outgoing instead of getting an incoming where this ends up being the listener. This is going to be the outgoing connection that is going to go to our attack box. So on our attack box, now we need to create a listener on port 2222, which is going to be very basic. So LVNP 2222. Now we have our listener on here, and now we press enter on this side. Connection refused. Why is our connection refused? Let me see, did I put the wrong 164.207? That's fine. 2222 is fine. Make FIFO. Maybe the command was misspelled. So let me check this out. Oh, dude, I used the wrong port right here. I only used 2220. I'm supposed to use 4 twos instead of 3 twos. So we're going to do this and add another 2. Now we have a Netcat listener on the correct port. So now I can do this again. And there we go. We got it. Yeah. Hell yeah, buddy. So that means that we now are connected to this machine from this machine, which means I can now run who am I here. Is that right? Or no? Let me see. Oh, okay. Never mind. So yeah, it's still on this side that we received the shell. So which means that we are now, yep, correct. Hell yeah. Okay, cool. So both of these versions worked. We were able to pull off both of these versions inside of our Linux box right here. So let's go to the next one and see what the next one is. So we did SSH using techniques in task 8, and we did that. Now a reverse and bind shell using Socat on the Linux machine. Try both the normal and special techniques. So let's do that. So we're going to cancel. Let me see if I can cancel this. Okay, great. So I canceled it and I'm still inside of my SSH session, which is excellent. And this also canceled out this thing. So I'm just going to clear this out. And I will go here and I'll clear this out. So now we're going to use Socat. So let me see if Socat is even inside of this machine. Let's see if we have it. Okay, there we go. We do have Socat. That is great. This is a really useful command. I recommend that you get very familiar with this command. So we basically are looking inside of the root folder for anything that has the name Socat, and then when you do to-dev null, it means just don't show me any error messages. So I'm going to show you what this looks like without the to-dev null at the end, and then you'll see a bunch of error messages that load. You see all these permission denied, and then now you have to sift and sort through all this crap to try to find out what's actually useful, which is not helpful. So we just do the to-dev null at the end, and it only shows up the stuff that is actually useful to us. So we do have Socat here. which means we can use it, and hopefully we also have it here. So let's do name Socat to dev null, and that should also hopefully, yep, there we go. Okay, we have it. So now let's go look at the Socat commands here, and let's do a basic one. So we'll do a basic connection with TCP/L, and then we'll try to do a SSH version of everything. So let's do a TCP/L first. So Socat TCP/L port. I'm just going to open this up on my other window so that I can just type it out. All right, here we go. So on our listener is, yeah, so our listener is going to end up being, we'll do this. We'll do it on this side. So we'll do Socat, and that's the command. So Socat TCP/L on port 2233, and then we put a dash at the end of it. So that's going to be our listener, and that should work. Didn't give me any error messages, so I think it's working. So now on the other side, I'm going to type the command to connect to it. So we're going to do Socat Okay, let's try it the opposite direction and see if that works. So TCP/L is going to be on this machine. We'll do that, and that'll be our listener. And then on this side, we'll do a, can I cancel that out? Oh shit. Wait, what? It was already connected? What? What just happened? I feel like it was already there. That was weird. Okay, so let's try this one more time. What is my attack box IP? 10.10.164.207. And then execute bash li. Did it not work? What's happening here? Oh, it did. Look at that. It did work. Look at that. It's executing everything on both sides, you guys. That's crazy. So print working directory. We're inside the shells. Let's go back one. Print working directory. Look at that. It's working on both sides. That's so cool. Okay, so this was a basic TCP connection. So what we're going to do is we're going to create a certificate so that we can do this special version of the TCP connection. Or let's see, what is this? The file TTY. That could be another one that we can do, a special version. So the special command would be this thing, and we can create a listener using this command very basically, and then we would do the execution of the other side like this. So let's do the listener on our machine. I think that's what we're supposed to do, is that we're supposed to do listener on our machine, and then we execute this because it's saying attacker IP. So we're going to execute that on the SSH machine. So let's first do the listener here. That's my listener. And then we're going to execute this thing now. And that's the specialized command for our victim machine that we SSH'd into. So, oh, it gave me the, look, it gave me the line right here. So I think it worked. So our Socat shell did work. We can also try to move on to, let's see what the next one is. The reverse shell, look through payload all things, and try some of the other reverse shell techniques, try to analyze them and see why they work. So let's go to payload all things, and we have some of these other things that we could possibly do. So what would be an interesting one? These are the Windows interpreter ones. We have Socat Telnet. Let's see what the Telnet one looks like. What? It doesn't work? Okay. Let's move on to the, because I also want to do one that I can kind of work with, because some of these things I don't know how to work with. Why are these things not working? What's happening? Let's do, I'm gonna try one more Python, because Python is my, okay, you know what? This is annoying. None of these things are working, and this is kind of annoying. Am I offline? I'm not offline. Okay, well, whatever. I guess the payload all things thing doesn't work. Whatever. At least we got our Socat shell to work, and we got a few of the reverse shells and the bind shells to work, and we got the Netcat shell, both of them to work on our task 8. So I'm pretty happy with that. We were able to pull this off. We pulled this one off. We SSH'd and we pulled the Netcat stuff off, and we got a Socat listener to work too. Payload all things is not loading, so that's kind of annoying. So let's switch to the Windows VM now, and let's upload the PHP reverse shell on the Windows VM. Let's see, or let's try it. It feels like it's not gonna work because the way that they phrase this. I don't remember if it's gonna work or not, but I'm going to cancel the this machine. So I'm gonna close this one out, terminate this one, and then let's start the Windows machine. And we're gonna use this, and this is the username and password for this if we wanted to RDP into it, but we don't need to because we're using the attack box in this case. But if you wanted to RDP into it, then you could RDP into it using this information. But okay, so let's go back to our practice questions, and we are going to start with the where is it? Right here. Try uploading, activating PHP reverse shell. Does it work? So let's try that. Okay, so there we go. We got our Windows machine up. So the first thing that we're going to try to do is we're going to update the PHP reverse shell script with this IP address. So first I'm going to go here, I'm going to go here, and I'm going to go to the upload. Okay, so here's our Windows upload, and we're going to go here, and I'm just going to close one of these things right here, and we'll cancel that out, clear this. So now what we need to do is we need to upload a web shell on the Windows target to try to obtain a reverse shell using Powershell. So web shells for Windows, and I think this is it for the Windows. So let's see. Before I try this one, I want to first try, actually I think this is what we're supposed to put as the command at the end of this thing. I think, yeah. So, alright, so I already have this, so I'm going to try uploading this first, and then from here we will go and try that long-ass command. So let's go to, where are we? We're supposed to go to root, right? User. Okay, there's the shell PHP. We're going to open that, submit this thing, and there it is. And so now what I can do is I can go and create my Netcat listener one more time. And we'll do a Netcat, what is it? Yeah, right, Netcat, yeah, I can do a Netcat listener on any port that I want. So I'll still do the LVNP, we'll do 2323. And that's gonna be our Netcat listener. And so what we're gonna do on this side is we're gonna type in this long ass command at the end of uploads.shellphp, and then we're gonna append it at the end of this thing where we're gonna do cmd equals, and then we're gonna put this long command, this entire thing, but it's because it's been URL encoded, so that's why it looks like this. So you do paste, and then I gotta come all the way over here at the beginning of it, and I gotta change the IP address that's here. There we go. This part where it says IP and port, I need to change the IP to 10.10.164.207, which is my attack box IP, and the port, which was, I think it was 2323 is what I chose. Right, 2323. Yeah, so that should work. So let's see if I press enter here, what's gonna happen. Connection received. Heck yeah. So I think it's dir since we're inside a Windows machine. And there it is. Look at that. And I'm inside the uploads folder. That is cool. I mean, it's insane that it was such a long command, but it totally works. So now I can go back and I'm inside the htdocs, and what is in here? What's inside this docs? We have the favicon and style. So let's go back and try to find some other things in here. What do we have? The uninstall. Ooh, test PHP. Ooh, interesting. README. The README en. Let's see what's inside the README en.txt. This is inside the README file. The first root password is queried by the MSQL server. My pure blah, blah, blah. Have lots of fun. Localhost. It's not really anything useful, but hey, we're getting in their files. We have all this information now. Fancy. I'm very, very excited. Oh, look at this. Got a username and password for the test user and password for Mercury. User root, no password. There's no password for the user root for their MySQL database. This is bad, you guys. These guys are SOL right here. That's crazy. I can't believe they did that. And so it's inside MySQL, right? So if I wanted to go and do a dir here, there should be a MySQL here. And there is. Oh my gosh. See, this is all bad. So they have MySQL, there's root, and there's no password attached to their MySQL. Man, if I wanted to destroy these guys, I probably could right now. Okay, so what do we got next? We got a web shell, and we got a reverse shell using PowerShell. The web server is running with system privileges. Create a new user and add it to the admin group. Then log in over RDP or WinRM. Let's do that. So it's going to be under, is it next steps? Yeah, it is. So net user, username, add. And that is also something that we could easily do since we have root privileges over this web shell. So since we're in PowerShell, we're going to go into the root folder here, and I'm going to do net user, Hank Hacks. I'll just do my first name, last name, Hank Hackerson. And then I'll do got you mofo as my password. And I'm going to add that. And I got my new user. Now I'm going to do net local group administrators, Hank Hackerson, add. And that has been done. So now I got my username. We're doing some exciting things here. So we're going to do free RDP. U is going to be Hank Hackerson. And the password is going to be got you mofo. And the virtualized machine is going to be the 10.10.196. Or no, is that the right IP? No, 168.231. 168.231. Enter. Connected. Look, we got it. I am here as Hank Hackerson. I am inside the machine. I can't believe it. I mean, I can believe it because we got root privileges or system privileges, and we were able to do that. That's crazy, bro. These fools left themselves open, and they are SOL. So let's try to do Socat and Netcat to obtain reverse and bind shells on the Windows target. So that should be something that we could probably potentially interestingly do. And let's go here and see what we can do with Netcat on a Windows machine. So let's see Netcat for Windows. So Netcat, it seems to be basically the same thing for Windows, but I think what needs to happen, and I'm just going to close this out just so I can save some RAM here. I think I need to go into Tools inside of the Windows machine, and that's where it would be. So if I go into Tools, there it is, and then from here we have Socat and Netcat. Okay, there we go. So we have Netcat here. as a listener. So let's if I did netcat exe and then lvnp 2323, is that not working? Okay, let me see if I have the right syntax here. Let's see what we can do here. Okay, unfortunately, I'm actually having trouble with this. I tried using Netcat and Socat to try to connect to the Windows machine, and I went on both sides where I tried to create the listener on Netcat on the attack box, and then I tried to execute Netcat as the outgoing connector. That didn't work, and I reversed it on the other side where I tried to create the listener on the victim machine on the Windows, and then do the connection here as the listener, excuse me, or basically the vice versa of this. It's also the end of the day, and kind of running on fumes, so I feel like this might be affecting it. I'm gonna try to see if I can switch the PowerShell here instead of PowerShell to command line like cmd.exe and see if that works. Maybe that might be the reason why it's not working. And if that doesn't work, then I'm just going to move on to using a interpreter and multi-handler to connect to the Windows machine instead of using Netcat and Socat. So let's see. Okay, so I basically reconnected to RDP using the Hank Hackerson admin username and password. So let's see if I can go to the tools here, and from here, if I try to run Netcat as a listener, let's see if we can do that. That might be helpful here. Hopefully it works. What just happened? Oh yeah, it does need to be on the command line because now it's saying that it's actually listening on. See, I'm so glad I didn't give up on this, honestly. That would have been such a waste if I gave up on that. So it can't work on PowerShell. It actually works on command line. And that's the issue that I was just having. So now I can actually run this and it'll probably connect now. I'm super excited. So NC now we can do 10, 10, 168, 131, and then do it on port, what is it, 7676? Oh, it worked. It totally worked. Look at that, it actually worked, and the commands are running both on both sides. So if I run who am I here, it also runs it on here, although it doesn't work. So if I do uname maybe, it worked. I mean, the commands are actually showing up on here, so the connection is done and everything's run, but it's actually not giving me the output of my terminal, which is kind of annoying. But it did work because these things actually showed up on this side. I think it's maybe just a lag that's happening between the two machines. Let me refresh my screen to make sure that these things haven't timed out on me. I feel like maybe they did time out on me, so let's do this and zoom out. No, the attack box is all good too. So it could just very well be that the connection of this thing has timed out a little bit. But apart from that, it did work. So I'm just excited that the connection actually went through, and it worked because I was using the cmd.exe instead of using PowerShell. That was like apparently that's a big deal. Apparently that's not a good idea. So I'm just going to close this since we already have our RDP inside that window. Inside that machine, we have an RDP, so we can use that. I'm going to close this and close this terminal, and it should say on this side that it is ended. Yeah, it's totally lagging, but whatever. Okay, from here, let's zoom out of this. I don't know why this is not letting me. So we got all of that. So let's go to the questions where we are. So we got the Netcat. At the very least, I got Netcat to listen back to it, and we had to use the cmd.exe. Now let's get a 64-bit Windows interpreter shell using msfvenom and upload it to the Windows target, activate the shell, and catch it with multi-handler. Experiment with this to see what we can do here. So let's see. So this is the basic command to create a reverse TCP shell. using msfvenom for a Windows machine, Windows x64 machine. So I'm literally just gonna copy this, and I'm just gonna change the host IP and the host port into our information. So I'm gonna paste this here. Let me see if I could do this. There we go. I'm going to change this to, let's do 7777, and then we'll change the IP to the attack box IP real quick. And we got 10.10.164.207. And that's going to take a couple of seconds. And while that happens, I'm going to learn how to transfer my shell, because they did give us the invoke web shell command here. So invoke web request URI is going to be the IP address of what I got, including the thing, so on and so forth. So this is going to be the command that I'm going to run inside of my PowerShell. And there we go. I got my shell.exe file. So I'm going to create a Python 3 HTTP server, and we're going to serve it on port 8000. And on this side, let's see if I can just do invoke web request. And what is the full invoke web request? And then URI, got it. URI, and then we're going to do 10. Why can't I type in here? This is annoying. 10.10.164.207 on port 8000, and it's going to be shell.exe. That's what we're going to download, and we're going to designate an out file to it. So out file is going to be C what is it? C users Hank Hackerson users Hank Hackerson desktop, just like that. All right, so what I'm gonna do is I'm gonna try to put it inside the temp folder. Maybe that's what the issue was. So let's go here, and we'll do this whole thing. And from here, we're just gonna do, instead of this, we're gonna do Windows, right? Maybe I gotta do 2 lines. Windows, there we go. Temp, there it is. So Windows temp, and then I'll do shell.exe. Yeah, it worked. Oh, that's weird that I had to do it inside the temp folder. Okay, so now I am going to now go into what's the next step here? We've transferred it, and since we have transferred it, we can now implement our msfvenom payload here. Okay, I think I had to change the port that was attached to my, because I also did a, so I had to change the port that was attached to the payload that we created using msfvenom. So I changed it to 7788 this time around, and now I'm gonna download it one more time on my Windows machine, and there it is. So now what we're gonna do, and hopefully this time it'll actually work, is we're gonna do our Netcat listener, and it's gonna be on 7788 as my port, and there you go. Now it's listening. So now all I gotta do is just run this thing right here. So C Windows temp shell1.exe. Look at that, we got our connection. This is so awesome. So we got our connection using our msfvenom payload, which means that I can run dir, right? See if it'll work. It says it's connected, so I don't understand why it wouldn't work. Yeah, this is the part that's confusing to me, because it says that I received it. I have the connection received on this thing, but it's not working. So maybe I was supposed to, I think the thing was that we do the multi-handler to use our payload. I think that's what I need to do. So instead of using Netcat, I think I can use the multi-handler. So I'm gonna cancel this one out, and I'm gonna go to MSF console, and I'm gonna use the multi-handler to connect to the shell that I just created. And I am now inside MSF console, And so we're going to use the multi-handler. And now we're at the exploit, so we're going to do show options to see what we need to set, which is our L host, which is our host that we got to set. So L host is going to be the listening host, which is the attack box, and it's going to be on that. And then the port that I assigned was, what was it? The port that I assigned was 7788. So 7788 is the port that I assigned. So set L port is 7788, and that's all good. Now we're going to run it, and that should run in the background. So start a reverse handler, and from here I'm going to run my last command that we had here, or not our last command, but the one that ran the shell. Session is not valid, will be closed, and the session was closed. Oh, I used the wrong payload, I believe. Yeah, I was supposed to use Windows x64 shell reverse TCP, because that was the payload that I created using msfvenom. Yeah, Windows x64 shell TCP. Okay, so I need to change my payload first in order for this to work. So I'm going to stop that. There we go. And we're going to do set payload. Okay. Back, and then use multi-handler one more time, and then set payload to Windows x64, Windows x64 shell reverse TCP, and that's my payload. And show options, and so my everything's all good. The IP address is set, the L port is set, and now we are going to run it one more time, see if that works. Start a reverse TCP, run the shell, sending stage 1. Yeah, it totally worked. Okay, so what worked was that I created the payload with msfvenom, and it was a Windows x64 shell reverse TCP payload, and I set my, the attack box IP as my IP, and I set 7670 or 7766, whatever the port was, 7788. I set 7788 as the port number on that payload, and then I transferred it to my temporary folder on the Windows machine using the invoke web request, and then I transferred it. As you can kind of see here already, this is the full command. So invoke web request, URI is the IP address of my attack box, 8000 was the port that I was using for the Python web server, and then I took that file and I outfiled it, meaning I exported it inside of the Windows temp folder as shell1.exe. So that's where my payload was sitting inside the Windows machine. And then from there, I needed to create a multi-handler using MSF console. So I went into MSF console and I used the multi-handler and I set the payload as the Windows x64 payload. And once I set that, the L host is at the listening host, meaning the IP address of my attack box. The L port is 7788, which is the port that I designated on my payload. And then I ran the payload, right? I clicked run on the exploit right here, and it started the reverse TCP handler, and I went right in here, and I ran this executable, which is my payload executable, and lo and behold, it gave me the connection right here. So we are now connected to our Windows machine, users, Hank Hackerson desktop. So I should be able to run a dir command, and there is the stuff that, there's nothing inside the desktop, but if I go back to the previous thing and I run dir, I can see all these things, and I can go inside Hank Hackerson's documents, which is also empty because I literally just created this user in a previous exercise, but it worked. It totally freaking worked. So I'm super excited about the fact that that worked. And I think that was the last one for the multi-handler. Activate the shell and run it with multi-handler. We did that. And staged and stageless interpreter shells for either target. Upload and manually activate them, catching the shell with Netcat. So let's see if we can do any kind of a interpreter session for our Windows machine. So I'm not going to abort my session here, but I will. Can I exit it? I can. There you go. So now what I'm going to do is I'm going to search for interpreter and see what interpreter shells that we can find here, interpreter payloads that we can find here. This is a good one right here. Payload Windows x64 interpreter reverse TCP. And that's number 300. I think there's a lot of other ones here. Let's see what we can find. Reverse TCP, reverse TCP, reverse HTTP, interpreter reverse TCP. Yeah, I'll just use the x64 interpreter reverse TCP. So that is number 300. So let's see if we can use that one, 300. So use 300 and it changed it for us over here. So we're going to do show options and it's going to show us what we need to do. And it's already set. So module options for this payload right here. All I got to do is I got to set the listening host, which is going to be my IP address for the attack box. So that's going to be set lhost as 10.10.164.207. And I think that's it. So I can just run an unknown command run. What do you mean unknown command run? What? So exploit maybe? So let's do exploit. Oh no, this is a payload. So let's go back. I can't do, I'm gonna do back here. And let's do search for interpreter. And we don't need a payload, we need an exploit. So that's what I needed to do, is I needed to find an exploit instead of a payload. And that's the thing that is very, very important here. You know what? I think there's something else that I can search for that we've used before. So let me see if yeah, so there we go. So there's the Eternal Blue, which I think gives us a interpreter session. So it's an exploit Windows SMB interpreter. Let's see, we can also just see inside the interpreter, where is it? Multi-handler is probably inside this thing. Okay, so what I think I needed to do, since it's a payload called Windows Interpreter Reverse TCP, what I'm gonna do is I'm gonna go to the multi-handler one more time, and from there I'm gonna set my payload to be the Windows, let's see, Windows Interpreter Reverse TCP. And there's my payload. And now show options. So it should show me the options for this. And everything's set for this already. So I might be able to just run this now. So let's see if this actually works. Okay, so Eternal Blue, I was on the right path originally. Eternal Blue actually does have an interpreter reverse TCP that's already set in it. And this thing, I think, just runs as itself. So if I just run this, the following option has failed the R host. So I need to set the R host. Yeah. Yes. We're on the right path here. So we need to set R host to the IP of our victim machine, which is going to be, in this case, 168.231, 10.10, 168.231. And then let's run this. Okay, so this thing, at the end of it, it says, does it work? And when I ran this multiple times, I ran it with the RDP window that was open. It didn't work. I closed it and I let it kind of reset, and I ran it with just no RDP, and I ran it the same way. And I've used this before in other videos, and it has actually worked for me in other videos. And I didn't need to do anything prior to this. I had set it to the payload that originally it came with. I have set it with the payload, and I'm gonna try this right now, which is like the generic payload that comes in, but it's not gonna give us a interpreter session. I think it'll just give us like a regular session. So it's the generic bind TCP payload. So let's do use, let's see, use show payloads, and then use one. Defaulting to interpreter reverse TCP. Okay, so show options. And then I have this set up. And then do I have my R host? I don't, so we're gonna set our hosts to the IP address that we have here, 168.231. And we're gonna run it. Yeah, and it keeps giving me the same freaking issue. So it says it's unavailable or it's already in use, but it's not. So that's what's annoying about this. So I'm guessing the answer is no to this question, because there is a question at the bottom that says, does it work? And it doesn't work. It won't do anything here. If I try to connect it and then try to run it with a Netcat, that would be the other thing. We tried to connect it already with our RDP session, and that worked. So I know that that works if we transfer the payload and we reverse the connection using a multi-handler. It didn't work with Netcat because that was the first thing that we started with. I don't know if you remember that. But we started with Netcat as our reverse listener, and then I switched to the multi-handler. So it didn't work with Netcat when I did it. It did work with the multi-handler of MSF console. So I truly believe that the answer to this is actually no over here. It won't work because the first thing that I did before I went to the multi-handler, right here where it says activate and catch it with multi-handler, before I went to multi-handler, I actually started with Netcat and it didn't work. And then when I switched to multi-handler, that did work. So I know I'm repeating myself over and over, but I'm also just saying it out loud just so I can rest assured that I took the right approach with this. If you do run this and then you're able to make it work somehow, I really would love to hear from you. So please let me know in the comment section if that actually worked for you. But that's it for this. We're actually done with this. This was a long session because I had to troubleshoot a lot and I had to try to figure certain things out. It's been a long time that I've done the What the Shell video or the What the Shell room. So this was actually a great refresher for me to go through some of these concepts, and I did do a lot of trial and error. So by the end of this, I'm going to have a nicely edited video, so you're not going to see a lot of the trial and error stuff. You'll only see the things that are actually useful, and hopefully the video itself will actually end up being useful to you. But that's pretty much it for our What the Shell room. This was a long one. There's 15 tasks on here. Technically the last two aren't really tasks. They have just different machines that we're going to connect to. So technically it was 13 tasks, and it was a nice long series of questions that were associated with it. But we did create a lot of shells in this thing. We created binding shells, web shells, reverse shells. We created msfvenom payloads. We created what else did we create? We created the multi-handler with Metasploit. We created Socat, Netcat. We created a lot of good stuff with this thing. So I'm happy with the results of it. Hopefully you learned a lot from it as well. And yeah, I think we're good. We're good for this one. We're going to wrap this one. If you did learn from this, and if you were able to have a lot of takeaways from it, I would love to hear your takeaways in the comment section below. If you're studying for your PenTester or ethical hacker or security analyst certifications, I invite you to I invite you to like, subscribe, and turn on the notification bell so that you get notified the next time a video comes out. And definitely drop your questions and takeaways inside the comment section, and I will get to them as soon as I possibly can get to them. And we'll see what happens next. I am yawning perpetually, so I apologize for that. It is getting quite late over here, but we were able to finish this. I'm glad that I stuck it through all the way to the end. So we were able to finish it. We got a lot of good shit done, and hopefully it served useful to you. Would love to have you as a part of the community. So please subscribe and turn on notification, do all that good stuff. And yeah, I'll definitely make sure that I respond to all the comments that come in as well. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Later.